Today we're going to take a look at what's called repeated factors in partial fractions. It's something that comes up a lot when we do our Laplace transform stuff. I'm going to do this example. I'll walk through a whole lot of the y. And then I'm going to do a Laplace transform problem that uses this. And then I'm going to give you one more to do. We'll see if that probably won't fit into one video, but we'll just roll with it. So the repeated factor here is that this x squared is an x times an x. So I've got an x times an x times an x minus 3 in the bottom. So that x is repeated. So the way that I think you would intuitively try to tackle this is to do a over x squared plus b over x minus 3. Now, what I'm going to do is walk through doing it this way, and you'll see, I hope, why this doesn't work. This is not how we do it. Instead, I have to add an extra piece. And instead of just telling you that we add the extra piece, I really want you to see why. So I'm going to try to solve for a and b given this setup. In terms of splitting this guy up into different pieces so that I could inverse Laplace or take an integral, whatever I need to do, right? But to split these up, I need to take some extra steps. So the first thing I would do would be to multiply by the denominator right here on both sides. So if I do that, I'm left with 3x plus 4. I'm not using cover up because using cover up does not show the problem. So I'm going to go old school way, which would be to multiply by that denominator, equals, all right, the a is missing a x minus 3 when it cancels, when the x squareds cancel. And then I get a b times, what do I get, x squared. So from there, let's rewrite this. I get 3x plus 4 equals ax minus 3a plus bx squared. Now, what I want you to see is that over on this right-hand side, I've got x squareds, x terms, I've got an x squared term, I've got an x term, and I've got a 1 term, right, a no x term. So I'm going to have 3 equations out of this in order to make the right side equal to the left side. I'm going to have an x squared, I'm going to have an x, and I'm going to have a 1. So my x squared term is going to be this b, right? And notice there are no x squareds on the left side, so really it's 0x squared. Ooh, that was not good. Squared plus that. So what I've got is bx squared. Well, that's equal to 0x squared. What's that tell me? I think you should see that b needs to be 0 to make that true. So now let's do the x terms. So let me just cross off things that I've done. I've done that and that. So now let me do the x terms. So I've got a ax on the right side there, right here. Well, that's got to be equal to 3x. I think you should see that that means that a would have to be 3. Okay, so far so good. No problems yet. But wait till we do the next. Oops, come on, man. This, and I did that, and that. So you should see there that the only pieces remaining are that minus 3 and that 4. So when I do my 1 term, trying to set up to figure out what, things would be, I get minus 3a is equal to 4. And then, well, that clearly tells me that a is equal to negative 4 over 3. And you should see that this is impossible. I can't have that. I can't have a be 3 and a be negative 4/3 at the same time. So what that tells me is that something went wrong. That something that I assumed went wrong, or some math that I did. All this math is right. My assumption was the a and the b. So in order for you to see how we're going to fix this impossibility, I'm I want to point some things out about that I think you already understand about math. So let me pause for a moment. I'm going to pop something up here. Okay, so this right here is just a totally random system of equations. It doesn't really have anything to do with all these calculations up here. But what I want you to see is that if I had this system of equations, 3x plus y is 7, and 4x minus 2y is 2, well, we could solve that. You know, we could use elimination, substitution, we could use a calculator, something like that. I could figure out what x is, or what x and y are. Now, why is that? It's because I have two variables and two equations, right? Remember, if I have like a x and a y and a z, right? 3x plus y minus 2z equals 7. Well, if I had that, I would need to have three equations to be able to solve for x and y and z, right? So two variable system of equations needs to have two equations to be able to solve. Three variable system of equations, when they're linear like this, needs to have three variables to solve. So I think you should see that up here, we had three equations. So I was trying to satisfy three equations, a 1 equation, an x equation, and an x squared equation, but I was trying to do it with just two variables. And that's what gave me this impossibility. I needed a to be 3 to fit all this stuff, and I also needed a to be negative 4/3. So the question is, what do we do to fix that? So you should see that we are stuck with three equations, a 1, an x, and an x squared. So to solve, I need to add a third variable. So let me copy this up here and put it down here. And I'm going to get rid of that. What I want you to see is I've got to have, it's partial fractions, right? If you accept that I have to add a new fraction with a c on top of it to do this, the question is, what goes right here? So I could so that's my third variable, my c. So say I were to add, let's choose a good color. Say I were to add an x plus 2. Well, that's not going to work. Why is that not going to work? Because if I were to add an x plus 2 and try to set it equal to this thing, right? If I were to make that denominator x plus 2 and set it equal to that thing and do some algebra, well, the common denominator, the least common denominator for this entire right side doesn't match this. So I'd have to insert an x plus 2 over here, right? So I'm stuck. I can't add an x plus 2. I can't add an x plus 7. I can't add an x minus 10. There's actually only one thing that we can add or that we can put in here. That doesn't work. I need to have an x. It has to be an x. Why is that? Because I have to choose from things that are already existing down here. I've already taken the x minus 3. It's over here. I've already taken the x squared. It's here. So what do I got to take? I got to take an x. You may say, well, why can't I take an x times x minus 3? Like, that seems like a reasonable question, right? Well, here's the problem with that. That would not be split up in partial fractions. This, if this was in the denominator of this thing, would have to be split up even more. So it wouldn't help us to split this guy up into this and c over that, because we need to do some inverse Laplaces, or in some cases you need to integrate, right? So I need to have an x there. Okay, so hopefully, I have only one option based on the denominator of the LHS is left-hand side, so the left-hand side of this equation. I have to have an x there. Why do I have to have an x there? Because if I try it like this, it doesn't work. I clearly have three equations. I need to have a third variable, so I throw the c in, and what's literally the only option that I can put under there is an x. So hopefully you see that. I could talk about this with like actual fractions and numbers and stuff like that, but I think it makes sense like this. Hopefully it makes sense to you. If we were doing this in class, I'm sure there would be some hands raised. So I've tried to explain it as clearly as I can. So that's the why. That's why do we do this. And now I'm going to show you how to work it out, and we can solve for a, b, and c. And I'll do some shortcuts that you guys are already familiar with. So I am going to multiply by the denominator, this thing right here, right? I'm going to be left with 3x plus 4 on the left side. Okay, when I multiply a over x squared by this, the x squareds cancel, so I get a times x minus 3. When I multiply the b's, the x minus 3's cancel, so I just get b times x squared. And when I multiply the c over x, this x cancels with one of those, so I get plus c times x minus 3. From there, I simplify a little bit. Remember, I have 3x plus 4. That'll stay the same. Or sorry, I'll distribute and stuff. So I get ax minus 3a plus bx squared plus cx squared minus 3cx is the way I want to write that. So hopefully you see that. I will, let's see, I got this and this are a 0x squared term. So those guys are all bam. And then I've got this and that and that. And then the 4 is going to be paired with this and that. So what I'm going to do here, instead of doing it out the way I did a moment ago, the way I did up here, like solving and setting up equations, I'm just going to do a matrix because you guys should be good with that. So my matrix, I got an x squared line, I got an x line, I got a 1 line. I got A column, B column, C column, bar, gap, matrix. Okay, so let's do the right-hand side first. X squared 0. Sorry, I mean the right-hand side of this. It's the left-hand side of this. We got it, whatever. 3 and 4. And then, all right, let's do the x squared line. I got a bx squared and a cx squared. So it should be 0, 1, 1. And then I've got, all right, my x's are, A has a 1, and then I'll cross as I go. So I did that, and I did that. I've already put all these in. And I just did that. So, and then 0, and then minus 3, got that. And then negative 3, and 0, and 0. So you could definitely solve that by hand, but I'm just doing it like this because, it's faster. We're doing calculus, not algebra. RREF it. I get A equals negative 4/3. B is 13 over 9. And C is negative 13 over 9. So what I can do then is plug those values in up here. And I'm going to pause for a moment. I just copied these guys up here, and now if I had to inverse Laplace that line, I could. If I needed to integrate that line, I could. I can do that stuff. I'm not going to talk about that one anymore. Instead, I'm going to do one more example. I'm going to pause it because I'm running short on time. So this one has x squared times x minus 2 cubed. Notice this is repeated twice, and this is repeated 3 times. So I want you to pause and see if you can write it out, not like solve it or anything. I don't want you to do that, right? Just write out what the next line would be with A, B, etc. How many do you think you would have? Hit pause right now. See if you can write it out. Go ahead. Here comes the next line. This guy was repeated twice, so it gets an x and then an x squared. This guy, well, I get an x minus 2. And then I get the next one, x minus 2 squared. And I get the next one, x minus 2 cubed. So I would have an A, a B, a C, a D, and an E. And now you may say, oh man, I don't want to do that with this. And I say, don't worry, I got more tricks and I'll teach them to you. I just really want you to see how we set this piece up. That's the goal of this video. How do I set these up? Hopefully you understand it. Thank you, and I'll see you in the next video.